I just want to show you an interface of Gemcom Minex. This is Minex 6.06. Actually, this is used for stratified deposit modeling. You can use it for geological modeling. You can use it for mining modeling. You can use it for pit optimization. You can use it for pit design and all that. So before we go into the step-by-step rudiments later on other trainings on how this is actually used, what you need to do, I want to show you the interface. You see the application, what it does. Is one of the highly recommended and highly professional applications you can use both for geological modeling in 3D, in 2D, and also for mining packages or other mining designs. It has so many menus. It depends on actually where you want to be professional, or actually where you want to concentrate. If you look at this, we have the software can give you so many things on borehole database. It has borehole database, so you can be a certified borehole database personnel, or you can also, it has also coal washability. It has seam modeling. It can explain, this explains how you can model a lot of seam, whether it's a double seam, single seam, and all that. It also has a module for pit design. If you want to specialize on design as a mining engineer, this is also good for you. Then also in reserve database. In database, reserve, you can also use that. You can also use it in schedule, in terms of production schedule by month, by week, by year, and so many years to come schedules. You can also in blasting, it can also be used in blasting. In earthworks, you can also use it for earthworks. So you can see there's so much you can use it for, especially in your pit optimization processes. You can see your pit optimizer is here. You can use it for that. But okay, let me just show you here. If you look at the Explorer menu, this is the table of contents here. There are basic folders you need to form, that actually you need to form while working with the application. Now, the first one, if you look at here, there are 3 basic folders where we'll have the grids, because most of the model or most of the things we're going to be doing here are actually done in grids. If you look at the grid file contains the AD quality grid, it contains AR quality grid, it contains bench grid, cost grid, merge grid, model grid, pit shell grid, structure grid, and all that. Now, there are 3 major folders you need to form. One is structure folder. It's called the structure folder. The second one is the model folder. Are you getting it? Yes. And the third one is the merge folder. If you look at, this is where all your grids are saved. If you look at these grid files now, this grid folder, it contains all other grid folder. But see the structure folder here. You see the structure folder, this is the model folder, and this is the merge folder. Now, how this thing works is this. Most of your geological work is done in the structure folder. From the structure folder, as you want to, because the software goes from geological model to engineering model. Do you understand? So most of your work in geological models are in structure folder. From structure folder, you go to model folder. This model folder is a folder that the mining designs makes use of. Do you understand? Now, the merge folder contains what the engineer is actually making use of. Now, for example, if you open up the structure folder, I'll show you the display. Now, for you to model any stratified deposit, the basic requirement, the basic data you need is what? Is the borehole data. The borehole data is the basic data you require. Do you understand? Now, let's assume here we've actually imputed our borehole. the borehole display. You go to borehole database, you can plot the borehole and see if there are boreholes. Let's see the boreholes we actually have in this. You know, this is the borehole display. In this borehole display, you can change the names of the borehole here. If you click OK, it will display the borehole. It has displayed the borehole. You can see this is a 3D window. Can you see it? It has displayed the boreholes. This is all the boreholes here. Now, the borehole has the collars, the collar names. You can see, if you can zoom in into one, this is R19, R01, R20, and all that. Do you understand? Now, each of these borehole has SIM. This is the SIM. Are you seeing it? The SIM name is CB. Do you understand? Now, this SIM is actually the mineral you are talking about. This is coal. You understand? This is this coal we are talking about here. I'm trying to model coal. Now, this is where the coal SIM are actually found. Now, in this place, if we display, go to borehole display again, and want to plot, I will say borehole display. Now, within here, we can actually change how the display looks like. If we don't want to, maybe SIM markers, we don't want to display them, we can uncheck it. The SIM width is 8 here. We can reduce it to 6. You see, it's reducing. If you want to increase it maybe to something 10, you see, it increases. You understand? So from here, you can control how the borehole displays. You get it? Now, that is it. Okay, looking at this, let's see, this is your borehole. Let's see the SIM roof. This is the grid for the SIM roof. If you bring in the SIM roof, you see, have you seen that the roof aligns with the roof of the SIM? Remember, this is the CB SIM. Have you seen it? It aligns. Then if we bring the SIM floor, which is the bottom of the SIM, it should align with the bottom. Is that correct? Have you seen it? Have you seen it? It aligns with it. Have you seen it? So now this is the thickness of this mineralization from here to here. Have you seen what this actually used to model? Now it has. We've done a grid for the roof. We've done a grid for the floor. Do you understand? Now there is no topography here yet. Have you seen it? Because it is the topography that we will use to calculate the overburden. Because from here to here is your overburden. Is that not true? There are no topography. So let's bring in our topography, which is the top here. You see? That is the topography suffix. Have you seen it? This is topography of the entire plate. Have you seen the topography? Have you seen it? You see how it is? So based on this topography, the application, we can use this to say from here to here is your waste. Now other lithological rocks and all that are not actually displayed here, but I'm just trying to show you the common parameters and how the interface looks. Now, if you look at this is in a structure folder. It's still raw data. Now, let's look at some of these things, how it looks like in other folders. Remember here, you can actually, this is amplify. You can actually amplify this and all that. Okay, we can clear everything here. Okay, let's look at the other folder, model folder. Model folder, you will not actually see anything. This is the thickness. SIM, you see? Roof. In the model, if you look at this, okay, let me show you. If you look at this SIM floor, SIM roof, You see, there is a bit different here. You see the shape of the same floor and same roof compared to the shape of the same floor and same roof in the structure. Have you seen it? They are not the same thing. Do you know why? Now, in the model, the model has taken shape of the actual crop line, subcrop line. Now, what it means that the model has followed a particular line to carve out the real seam floor and seam roof. Unlike in the other one that takes everything. Do you understand? Now, that is the difference. Let's look at in the merge folder. Clear it. Let's see the merge folder. Have you seen the merge folder is different now? The merge folder, everything is merged to the surface. Now you are seeing your pits. This is for, have you seen it? This is for mining now. In the merge folder now, we'll merge everything. Yes. So at this place now, you can actually, if you bring in the top, we can actually calculate. You see, it covers up. You see, we can actually calculate the volume of this. Now, okay, let me show you something. Let's go to the triangle. The triangle. You see, this is the triangle folder. Now, this is the triangle folder. In the triangle folder, you can see the pit itself, how they look like. Have you seen it? You see how the pit looks like? See top. You see the top? You see the pit itself? So on the triangle folder, you can calculate the volume of anything you want to calculate. If you go to triangle here, you can calculate the volumes, you can do arithmetics, you can do some subtractions, you can patch and you can cut. Then let's clear this. Now I have top merged here also. Okay, we'll have patch here. Have you seen it? So you can see how the pits actually merge with the top. So that is it. This is just to display what you will be expected to do in your next class, and this is how this actually looks like. Then let's clear it. So from this, you'll be able to understand the interface and the displays, different display window of this. They have 3D display. We'll have the drafting is another window here, and it has visualization window, and you have scheduling window. All these are different kinds of windows you can see here. Is that clear? Okay, so I think that is actually what I want to show you here before we go into step by step of how these things are actually built. Do you have questions on this? Yeah. Yes. Now, for example, if we go to plot borehole, we'll display this borehole. Now, you cannot start any work without having your borehole data. So we're going to show you, we're going to show you how the data are going to be presented. The borehole data must have your polar, you must have your azimuth, you must have your inclination, you must have your lithological unit, you must have your seam, you must have, so everything must be well prepared in your CSV files before you bring them in. Do you understand? So the borehole data must be complete. Then the quality data, I've not shown you the quality data. If you have quality data, almost can come in. Your geophysical data can also come in. There are so many things you can come in when you are building your geological models. Do you understand? So we will go, first of all, you will need to start from how to prepare your raw data. how the raw data looks like. Do you understand? There's a format your raw data should look like, and there's a way you have to bring them in. So if you don't have your XYZ, that is the polar coordinate, first of all, to start with, before you start anything, you can look at this now. These are the collars. Do you understand? For it to plot here, you have your XYZ. And the issue again here, when you're building your collars, is that the topo you're going to use must align with the collar coordinates. If you are using a topo that has some different with the collar coordinates, you will have some issues when building your models. So we'll come to that when we are going to deal with that. Do you have further questions before we go into another one? Okay, that's it for now. Thank you very much.